Okay, so Edatec have sent me a couple of industrial products. One is a 10.1 inch screen with a Raspberry Pi 5 connected, and also I've got this very cool Raspberry Pi 5 case, which I've already taken apart. It looks like this when it's inside the case, and that's how it comes with a pre-installed operating system on the SD card, but it also has an NVMe drive inside. But before I take it apart to have a look at that, I'm going to boot it up in a different way. This is the SD card that it came supplied with an OS on it. Pop this into the SD card slot on the Pi 5. And to take this out, especially when it's in its case, it actually comes with a set of tweezers. Now, I reckon they've done this because it's for industrial use, and obviously you don't want someone messing with it. That said, once you've got the operating system written to the inbuilt NVMe drive, then you can't get access to it. So I guess then you would remove the SD card anyway. But that's all in place. So what I'm going to do now is just plug in an Ethernet cable, nothing else. Because this device supports power over Ethernet. So that means if you've got a power over Ethernet device, like my TP-Link one, it can provide power to your device via this Ethernet cable. Now it comes with SSH enabled, so that means that you can access it over a network. So I'm going to launch Fing, which is a great way of finding out what devices are on your local network. So do a search, and one of them is a Raspberry Pi 192.168.1.150. So on my MacBook I can now open up a terminal and type in SSH Pi at 192.168.1.150, and then it's asking for the password, which is Raspberry. It's obviously worth changing that. And I'm into my Pi. So now if I was to type in, say, NeoFetch, you can see that it's up and running. And if I type in sudo raspi config, I've got access to all the configuration. Obviously there's loads more you can do. This is very much for industrial use. So if this Pi was inside a piece of machinery, you've got remote access to it and you can provide the power with just an Ethernet cable. So now I can choose to plug in my USB hub, which has got all sorts of things connected, and also HDMI to see if we can get a graphical user interface on the screen. Yeah, my monitor's already waking up, and there you go. So before I take it apart, I thought I'd write something to the NVMe drive. So let's close all this down. And this is just my USB stick. In fact, I'm going to unplug that because that's going to cause some confusion, because that's the same size as the NVMe drive. So if I start Raspberry Pi Imager and choose device, so Raspberry Pi 5, choose OS, so we'll go for the 64-bit version of Raspberry Pi OS, choose storage. So this is the NVMe drive that's already in there that comes supplied. So let's hit next. I'm not going to apply any settings, and I'm going to say yes to that. And then pop my password in, which is the default of Raspberry at the moment, and authenticate. So this is now downloading the operating system and writing it to the NVMe. The actual writing to the NVMe would be SUPERFAST, but it's got to download it. So let's come back when that's all done. Okay, so that's all done. Let's hit continue and I can close that down. So I'm going to shut it down and remove the SD card and boot from the NVMe drive for the first time. So tweezers, an SD card out, and let's boot that up. Okay, so it didn't need anything extra, the config.txt, to be able to boot that, which I'm surprised about. Yeah, and let's boot it up in the normal way. And we're going to update it. And we have a fresh copy of Raspberry Pi OS. You can see here, the power supply is not capable of supplying 5 amp power. Now, I'm not sure what spec the power over Ethernet is because it doesn't say in the information, but I'm also not sure if it's just a Raspberry Pi miscommunicating that because it doesn't see the official power supply. It seems to be working all right running through this Ethernet cable to power it, so I'm going to continue with that for now. So config.txt, and let's have a look in here and see if there's anything about PCIe. Yeah, there isn't. So this works with this drive without me having to do anything. I'm a little bit surprised about that because I thought you had to add various different things to it. Let's plug in the SD card. so I can copy over bits from the config.txt. So this is the SD card that came with it, and if we hit open, is that the one? Yeah, this is the one with config.txt. We don't need the other one, which is the data partition. So config.txt, you can see on this one I've just opened up, there's all this at the bottom, which is the bits that they've added. So what I think I might do, because some of this is to do with PCIe, is to do a speed test, then apply this and see if it makes any difference. So let's just close this down for now and start up diagnostics and run tests. Okay, that was super quick. So show log, and we have 387,786 for sequential write speed, random write speed 73,801, and random read speed 41,373. We need to have a look at my YouTube channel and see what that compares to, because I always put the speed tests in. I always do the speed tests in the same way as well. So I have had an NVMe drive on a Pi 4 before, which was this one, the fastest I ever had on a Raspberry Pi 4, 324,435. It's slower than the 387,786. Random write speed is way quicker, 73,000 compared to 20,000. Random read speed, 15,000 compared to 41,000. So much, much faster. And that's to be expected because the Raspberry Pi 4 only had USB 3. There wasn't a proper PCIe slot. But we'll see if we can get this faster by adding those bits to config.txt. Now if we look at, what have I got on here? So this is my fastest SD card that I've ever tried. So Samsung Pro Plus, we're talking about 55,727 compared to 387,786. We got 2,493, which was very respectable for an SD card, compared to 73,801, and we got 6,846 compared to 41,373. And it's the random read and write speeds that I'm concerned about, because they're the ones that make an operating system feel completely different, feel incredibly snappy and responsive. So really good results so far. Well, I usually do 3 and take the best one, so let's do that again. Okay, so I don't think I've ever had that before, where all of the sequential write speed is exactly the same. Random write speed, the best one we had was this one, 88,562. But I always go for the fastest, and again, these two are the same, look. 41,373. So I'm going to go with this one and delete these two. So Edatec IPC3020. And now let's change the config.txt. Let's add these extra bits in. So this is the SD card, and I'm going to grab the extra bits from here, and I'm going to copy those, and then I'm going to open a terminal and do sudo nano boot config.txt. The reason you have to do it this way is the boot partition is locked. You can't just write to it in the normal way, so you've got to do it this way. Let's go down to the bottom where they put it before and paste that in. There we go. And Control X and Y, enter, and reboot. Okay, so let's try again with diagnostics. I'll do 3 tests and then show the results. Again, the sequential write speed is exactly the same, and the random read speed was exactly the same as well. So those changes didn't make any difference to the PCIe speed. But I remember Jeff Geerling did a test where he changed it to PCIe 2 speeds, I think it was. Let's have a look. Probably this one. He was testing it very early on. Yeah, so optionally you can control the PCIe lane speed using this parameter. So let's add that in. So we've already got this one in. So Gen 3 is 8 gigabits per second, I guess that is. Anyway, the faster speed. So let's copy that in to config.txt. And we'll just bung it in here. And Control X, yes, enter to save. And let's reboot. Okay, so sequential write speed got a lot faster. 387,000 became 624,000, and in fact 648,000 here. Random write speed was 79,000, and it's gone up to 93,000 and 94,000. And random read speed, 41,000 becomes 42 and 43,000. So random read speed improved a little bit. Random write speed improved a huge amount, as did the sequential write speed. So yeah, really impressive. So the fastest random read speed, I'm going to go with this one in the middle. So that's the NVMe side of things, and as you can see, a big improvement on speeds, really impressive results. But also NVMe is much more robust and durable. So a real big reason to use an NVMe drive in a Pi 5. And let's have a closer look at what we've got here. So it came with a Pi 5, or it came with a Pi 5 already installed, and this is an 8 gig model. We can see we've got a aluminium cooler on here, and I've done separate tests on these. These are very effective, so there's no noise that this makes. We've also got this really thick aluminium panel on the base as well, which I'm guessing is all to do with heat from the NVMe drive, which is underneath, and I think that's touching. We'll soon find out as I take it apart. I've got to undo all these screws. Well, there's loads of screws. That's why I was doing all the tests before I took it apart, because if I don't manage to get it back together again, then at least I've done the tests. And whenever we have a look at the top as well, so this is the Ethernet hat. So this is the power over Ethernet bit. This is what's powering the Pi. And you can obviously still use the USB-C cable, but because of the novelty of being able to use PoE for the first time on a Pi 5 for me, that's what I was using. And that obviously transfers over to here. And then we've got this whole board which is going into the GPIOs, which is giving us the analog connections. Now they do talk about in the specs about a speaker, 3-watt speaker, and it's something to do with this, and this little adapter. And if you push in the little orange clips, it opens up like a speaker terminal, but I couldn't get it to work with a passive speaker. I did try it, but I haven't got instructions on that, but I will definitely look at that. And that just pops into here, and then when the board is in the right place, it tells you what these connections are. And I guess that it was A and ground and B and ground maybe for the speaker, but maybe I need to do something more with software to get it up and running. But it is really nice to see analog connections, so an analog speaker output and a microphone input as well. I usually use a USB sound card because I capture the sound separately, but it's great to see it built into this board. Right, let's take these screws out and carefully try and remember where everything was. I just want to see the NVMe drive in the bottom and see how that is, and see how it's set up to take the heat away from it, because I'm guessing that's what it is. This gets warm, but not that warm at all. So say it is really thick aluminium. It makes the whole case feel really solid. So let's start by undoing all these. That's the heatsink. But I can't see how else that comes off. That must go all the way down through. Is that enough? Be good if it is. No, that's not moving at all. Oh, there's one in the middle. Let's remember that. That's a much smaller one. What am I missing here? Oh, these two here as well. Is there something else it's pivoting on? Or is it just a sticky bit? Oh, we're off. Okay, so we have a thermal pad, and that's obviously taking the heat from the... Try and remember where that screw went. So that's taking the heat from the Pi. Oh, there isn't anything. So this definitely touches. You can see the NVMe drive touches that, but there is no thermal pad in between those two bits. Oh, stop dropping screws. No. I've learnt it's best to try and find them when you can straight away, because I've definitely lost screws before. So we've got a real-time clock. Little battery here, but no battery in it. We've got the NVMe drive, Gen 3, NVMe SSD, King spec. And 2242 is the length of it, so a 2230 would be shorter, a 2280 would be longer. A bit like some of these, well, these are all longer. Some of these are M.2 drives, some of them are NVMEs. This is an NVMe, and that's an NVMe, and that's an NVMe actually. So I don't really need to take that apart anymore. This is the PCIe cable, which is going up through here and along, and if we have a look, there's some writing on there. 10cm PCIe FPC B type. revision 01. Okay, so super impressed with that. I'm going to try and put it back together again just to show you what it looks like as it should be. So it must be that way around. Oh, put the NVMe drive back in and then back on there. I wonder if a thermal pad between the two would make a difference. Would it be needed? I mean, it is, to be fair, it's touching. But I wonder if a thermal pad would make it more effective. I nearly put this back together again, or in fact I started to put it back together again. Then I found this screw, and I'm guessing this is from the NVMe drive because I couldn't work out where it's from, and it looks like it goes underneath. So I think that was the one that went through the middle, which would have been on the NVMe drive, which, oh, doing it again. Yeah, it is. So this bit's come out, and that's because it was in there, and it was in there fine, but me undoing that middle screw, I didn't actually need to undo that middle screw. So it's like that, and pop that through. Yeah, that feels right. And so does that then sit? Yeah, that sits on there. So actually, it looked like it was like that, but it's because I'd taken that screw out. Now I can put it back together again. There we go, that's in place. So, Pi on here, and hopefully the next time you see this, it will be fully constructed. So here is the case all put back together again. So power over Ethernet. Obviously these are just the ordinary Pi 5 connectors. This is what I think is going to be for speakers, and possibly other things with GPIO pins. Plus we've got the microphone input, the headphone output. We've got these various different power lights that come on. We've got a ground screw here, and on the back the SD card slot, which you need those tweezers for, and a little power switch. And on the side, obviously just the normal Pi 5 USB-C socket and the 2 HDMIs. So really nice case, really well built, and obviously designed for industry, but yeah, it gives you really great functionality. So let's have a look at the screen. Basically the screen is a very similar setup to the other case in the way that everything is oriented in the same way, all the same lights and everything. Obviously this extra block on the end, which I can only assume is for to do with the display, but everything else is pretty much the same. So if I spin that around, you can see we've got a bit of venting there. We've got SD card slot and a power switch and normal HDMI output. So I wonder if we can get 3 monitors on this. That'll be interesting to see. But if I plug it in, I haven't tried this yet, but what will happen if I plug in a power over Ethernet cable? So the only cable I've got plugged in is this power over Ethernet. And let's see if it boots from the SD card. Came with an SD card, also came with an NVMe drive inside as well. We have an Edatec screen, so it does boot from the Ethernet cable, and we're in. And we get the same warning, SSH is enabled, and you can see that everything is working. And if I go into, where does Imager come up? Yeah, so Imager comes up here, and if I do choose storage, you can see that again I've got 128 gig NVMe drive in there as well. So I've moved to a different part of the room just to get a bit less reflection because there was too many windows next to me. So let's see what happens if we try and use the browser. I'm going to need the keyboard for that. The PSP Video HDR, and let's use the touchscreen for this bit. And just to show you things like pinch to zoom is nice and responsive. There's the video I want. Ah, we do get sound. I'm getting a bit of crackle, but it was turned up quite loud. Now because we have 2 outputs and also the display, we can do a triple screen display. So I've got touchscreen on this one, but also if I was to open something up, so say I opened Raspberry Pi Imager, I can then grab that with my mouse and I can take that up to this display or this display, and as you can see it's not struggling with it at all. I did have to change the orientation of the screens, so basically I've got left and right screen, and then this little one is the touchscreen display, but that was pretty straightforward. And you can see again I can pull it down or move it around. It's very smooth actually when it's moving between screens. I don't think I've ever had 3 screens on a Raspberry Pi before, but it's pretty seamless. So yeah, very, very impressive. And the screen is incredibly solid. It's really, really heavy. I mean, it's not meant to be carried around. It's meant to be put hung in a wall or on a machine or something like that. But it comes with these really solid bolts to put it in place. But yeah, really, really impressed. So great job, Edatec. Two really nice products. So this NVMe, PoE, and also Analogue output Raspberry Pi 5 case with a very solid heatsink on the bottom, and also this really solid, really well built screen. I mean, they're both industrial products, and you certainly wouldn't carry this around. I see it has got a camera. I didn't notice that before. Yeah, there is a webcam built in. I didn't see that on the menus anywhere, so I'll have to play around with that in a separate video, because this video has definitely gone on for quite some time. Anyway, I hope all this helps. Thanks very much for watching. Please like and subscribe.